Hello everyone, today we're going to look at solving 3x3 systems of equations. So we're going to use Cramer's rule to solve 3x3 systems in the same way that we did 2x2 systems. So let's say we have a system of equations. We have three equations, three variables. So we have 3x minus 2y plus z equals 0, x plus 3y equals 5, 2x minus 4z equals negative 1. We're going to have the same type of determinants that we had before, except now we're going to have four matrices. So D, we have the coefficients of our equations on the left-hand sides. So for x, we have 3, 1, and 2. For y, we have negative 2, 3, and 0. And for z, we have 1, 0, and negative 4. And then for the three variables, we have d sub x, d sub y, and d sub z, where for the x column, for d sub x, the x column has been replaced with the right-hand side, 0, 5, negative 1. For d sub y, the y column has been replaced with the right-hand side, and d sub x, the z column, has been replaced. So it's the same thing that we had with the 2x2 systems, again, except now we have three of them. And then similarly, x is d sub x over d, y is d sub y over d, and z is d sub z over d. We're not going to focus on how we find the determinants here. So I'm just going to show you the determinant and then give you the value. So I want you to pause the video before I give you the value, and you do out the determinant and make sure you get the same thing. Okay, so again, we're not going to focus on how to do the determinants. We have that in a separate video. So going back to that equation that we just showed, or that system of equations, d should be negative 50, d sub x should be negative 37, d sub y should be negative 71, and d sub z should be negative 31. So again, if you haven't already, go back to the original matrices and do out the determinants and make sure you're getting these same values. Once we have those, we plug them in, and simplifying, so get rid of all the double negatives, x is 37 over 50, y is 71 over 50, and z is 31 over 50. You want to leave them as fractions. Simplify them if you can, but don't put them into crazy decimals. Okay, 50 isn't that bad of a denominator in this case, but still, it's easier just to leave them as fractions. Don't forget that you should always check your answer, and we're going to do it in at least one of our equations. So make sure that 3 times 37 over 50 minus 2 times 71 over 50 minus 31 over 50 is 0 like it's supposed to be. So let's look at another one. 3x minus 2y equals 8, 2y plus 4z equals 10, and x plus y minus z equals negative 2. So D is, again, the determinant of the matrix with the coefficients on the left-hand side. So in the x column, we have 3, 0, 1. In the y column, we have negative 2, 2, 1. And in the z column, we have 0, 4, negative 1. If we do out the determinant, we should be getting negative 26. Now what I'm going to do next is I'm not going to do d sub x, d sub y, and d sub z. I'm only going to do d sub y, and I'll show you why after we found it. So d sub y, the y column, has been replaced with the right-hand side, that 8, 10, and negative 2. The x and z columns have stayed the same. And if I do it out, I get positive 26. So then y would be 26 over negative 26, which gives us negative 1. So now that I've found y, I can easily plug this into my first equation and find x, and I can plug y into my second equation and find z. So 3x plus 2 equals 8 gives me that x equals 2, and negative 2 plus 4z equals 10 gives me z equals 3. So if I have equations where the variable is missing in one or two equations, then I don't have to do Cramer's rule for all three variables, which saves me a lot of time because doing 3 by 3 matrices takes a little bit of work. So the major thing to take away from here is to notice that we have zeros in our x column and our z column, and there are no zeros in my y column. So if that happens, two of my columns have zeros and one does not, that's the variable I want to solve for. So the y column has no zeros, so that's the one I'm going to find, because again, that means that I can easily find the other two variables once I found that one. Okay, so I have, again, y is -1, x is 2, z is 3. I want to check that answer, so I'm going to use the equation that I did not use already. So I used the first and second, which means I'm going to check it using the third. So the third equation, if I plug in my x, y, and z, I get 2 minus 1 minus 3. That equals -2, and I know that it's supposed to be. So I check it off, I know that I'm right, and again, my answer is the point 2, -1, 3. Okay, so let's try it again. Using at least two determinants, so we have to use Cramer's rule to find at least one variable, so we need d, and then one of d sub x, d sub y, d sub z. If there aren't any zeros in my columns, then I do want to use Cramer's rule with more than two determinants. So we have to do at least two. We might have to do more depending on how many zeros we have. So 4x minus 3y plus z equals -2, 6y minus 3z equals 10, -2x plus 2z equals -5. I set up my D matrix. Notice I have a 0 in my x, I have a 0 in my y, and no zeros in my z. So that's going to tell me that after I find d, I'm going to find d sub z. So d should give me 42. And then I set up d sub z, so my z column has been replaced with the right-hand side. And if I do this out, I should get -84. Which gives me that z is -84 over 42, which is -2. Then I'm going to use my second equation, plug in my z, and solve for y. So according to equation 2, 6y plus 6 equals 10, which tells me that y equals 2/3. Then I'm going to plug my z value into equation 3, -2x minus 4 equals -5, which tells me that x equals 1/2. Again, once I've found all three variables, I'm going to check it, and again, I'm going to check it using the equation I haven't used already, which is equation 1. So 4 times 1/2 minus 3 times 2/3 minus 2 gives me -2, and that's exactly what I know it should be. So I check it off, I know that I'm right, and again my answer, x, y, z. For my last one, we don't always have x, y, and z, so in this case we have r, s, and t. So 7r minus 2s plus 14t equals -7, 3r plus 5t equals 0, -7r plus 3s equals 4. I set up my D, but now my columns are R, S, and T, not X, Y, and Z. And I look, and again I notice that my S and T columns have zeros, my R does not. So after I find D, I'm going to find D sub R. So D, you should be getting 91. And then we set up D sub R, so my R column gets replaced by my right-hand side. And if I do this out, I should be getting 65, which gives me that R is 65 over 91, which is 5/7. So again, I'm going to use the equations where a variable is missing. So equation 2, I plug in my R and I solve for t. So 3 times 5/7 plus 5t equals 0 tells me that t equals -3/7. And then I'll plug r into equation 3. So negative 7 times 5/7 plus 3s equals 4. And s should be 3. Now I'm going to use the equation that I didn't use, which is equation 1, and check it. So is 7 times 5/7 minus 2 times 3 plus 14 times negative 3/7 the negative 7 that it should be? I do it out, and I do get negative 7. And again, my answer is the numbers, the letters in alphabetical order. So R comes first, then S, and then T. So 5/7, comma 3, comma negative 3/7. Make sure that you always check your answer. That way you know that you're right, or you know that you're wrong, and you can go back and fix it. Okay, so make sure that you read through the section, try out some of the practice problems, and let me know if you have any questions. Thanks.